I hope you all good. And today in this NEET Physics, this recapitulation we are going on, that is second part, Kinematics, horizontal motion. In this we are going to discuss today velocity and what is average velocity, and you are going to discuss what is acceleration. So we are going to discuss what is acceleration, and then in this average acceleration and those are we are going to discuss, and then next equation of motion, equations of motion for uniform acceleration. Right, ACC means acceleration. Okay. So next, one dimensional uniform acceleration. Those formulas we are going to discuss. Okay. And not only this, we are going to discuss very important points to solve the NEET questions. So just we'll discuss these all points, and then we are going to the only problems related to this horizontal motion. Alright, before going to our class, let's close our eyes and do prayer. God, kindly provide your knowledge and wisdom to solve our problems and daily life problems. We ask in the name of God. Thank you, God. Alright, let's move on to the velocity. Let's move to the velocity. So what is velocity? Velocity is nothing but the rate of change of displacement, not distance here. Here you have to remember the rate of change of displacement of a body is called a velocity. Rate of change of displacement. Okay. So displacement means the shortest distance. Okay. So now what is the SI units for this? Meter per second inverse, and it is a vector quantity. It is not scalar quantity. So next we'll go for velocity. So in this velocity we need to remember these 2 points, very important. So what is average velocity, what is instantaneous velocity? So average velocity, if you want, so that time what we need to do is average velocity is equal to total displacement upon total time. So here it is, total displacement upon total time taken. And if you want instantaneous velocity means, what is instantaneous? I was already explained in the last video. Instantaneous is nothing but at that particular point what is the velocity. So if you want to find that, for example, like in at 2 meters distance, what is the 2 meters distance up to what is the velocity? Such kind of questions are there. That is called as instantaneous. Means at particular point what is your velocity. So for that we can write it as, so instantaneous velocity V bar is equal to d by dt of s bar. S bar is nothing but here displacement. Okay. So here you need to remember average velocity means total displacement upon total time, and instantaneous velocity means that is a d s bar upon dt. Still this we can write here. It is here dt is dividing, comes to your multiplication. So v bar dt is equal to ds bar. So now what we need to do, still we can simplify it. So just take the integrals and you'll get, see these are the formulas which you have to remember. So now we can take the integrals both sides, then integral v bar dt is equal to integral ds bar. So integral ds bar is nothing but s bar. So or we can say that s, so s is equal to So this we can write as this. We can write as S is equal to integral u dt. So, so that is about the formulas which you have to remember before going to learn some of the problems of velocity. So here, what is average velocity? What is instantaneous velocity? And so what is velocity? And what is its units? What is which quantity is that? So here once again, I'll tell to you that the rate of change of displacement of a body is called as velocity, and SI units are meter second inverse vector quantity, and average velocity is nothing but total displacement upon total time. Instantaneous velocity is nothing but Vva is equal to ds bar upon dt. So this is about your velocity, and let we take some example and we can understand it. And before going to this, still we'll discuss in detail about average velocity. Okay, next one in this average velocity, this is one of the important formula you have to remember this. So here from A to B, displacement is S1. So this S1 was done in T1 seconds. Then that time velocity is V1. Okay. So same method, and it is in the same direction. Okay. So in the horizontal motion, this point is C, and B to C is displacement is S2, and the time taken is T2, and velocity will be only one they given, that is V1 is a velocity. So they said only one clue, that is it was in the same direction. If that's the case, what is average velocity? So if that's the case, our average velocity is, so that time average velocity is nothing but S1 plus S2, means the displacement S1 plus displacement S2 upon T1 plus T2. What is our average velocity formula? You already remember that total velocity upon, total displacement upon total time. So here total displacement is nothing but S1 plus S2 upon T1 plus T2. So that is about your average velocity. So now, if in your examination how they will ask a question, so here it is, they will write as an object. So they may say like an object has a displacement 5 meters in 5 seconds, and next 10 meters displacement in 2, it is 20 seconds. Okay, an object has displacement is 5 meters in 5 seconds, and next 10 meters in 20 seconds. Now what is average velocity? Find average velocity given. This is your question. If they given, then what we need to do here, already given all the things. Now what is your displacement? First one, so S1 is equal to 5 meters, S2 is equal to 10 meters, T1 is equal to 5 seconds, T2 is nothing but 20 seconds. Then how to solve this? Very simple. So directly use formula, average velocity is equal to S1 plus S2 upon T1 plus T2. So S1 plus S2 means 10 plus 5, 15 upon T1 plus T2, 5 plus 20, 25. So 5 table, 5 3s are 15, 5 5s are. So we can write as 3 upon 5. That is your, in ABCD. In A, B, C, D, they may give like options are 4 by 5, 3 by 5, 2 by 5, 7 upon 5. So what is your answer? 3 upon 5. So in this way you have to solve if they given in that. So that is about your first important point. Let's move on to the second point. All right, next place what they given it is, that first displacement is s1 and second part displacement is s2 and time taken is t1, time taken is t2, and first one velocity v1, second one velocity v2, like that all are given. Then how to find average velocity is nothing but s1 plus s2 into v1 v2 upon s1 v2. You remember 1 and 2, s1 v2 plus s2. So you just remember this formula and just you need to solve. This is a shortcut. If they given all time and then displacement and velocity is given, then how to find average velocity. So given for example as t1 is equal to 3 seconds are given and t2 is nothing but 2 seconds are given, and now your s1 is given as 5 meters, s2 is given as 10 it is 7 meters given, and your v1 is given as, so that velocity is 3 they given, and then v2 is given as 4. So then how to solve this problem? Then it is very easy. v1 given, v2 given, and time given, this displacement is given. Then how to find this velocity? So what is velocity? SI units you remembered or not? So SI units of that, it is meter second inverse I said, or meter per second. So this may be the meter per second, this is also meter per second. Then how to use this? So directly average velocity I am directly solving by applying the formula S1 plus S2. 5 plus 7 is nothing but 12. So next one it is V1 into V2, 3 into 4, that is again 12 upon. Next S1 V2, so this is S1 and V2, 5 4s are 20 plus S2 V1, so this 7 3s are 21. So now add these both. So 12 12s are 144 upon 20 plus 21, 41. So if you want to simplify, you can simplify, or otherwise write like this only, that is meter per second. Okay. And so they may give in your examination in this method. Or maybe the options they may given this as 3.5 something, so 3.5 meter per second given, and in your examination options are given in this way. So it is 4.5, 5.5, 3.5, 2.5, and meter second inverse, meter second inverse, meter second inverse, meter second inverse. Then what is your answer? 3.5, that is 6. So in this way you have to solve. So that is about one, and let's move on to the another two more cases. Alright, next condition is this. Say here A to B, that velocity is V1, means first half is covered with velocity V1 object, and second half is covered with velocity V2. Then what is your average velocity? 2v1 v2 upon v1 plus v2. And if it is velocity and time only given, same direction given, then average velocity is v1 t1 plus v2 t2 upon t1 plus t2. Then for example here it is 5 meter per second and it is 15 meter per second given. Just substitute those and find your answer. 2 into 5 into 15, 5 plus 15. So 2 5s are 10 into 15 upon 15 plus 5, 20. 10 ones are 10 twos are 15 upon 2 is nothing but 7.5 meter per second. And same method here, time is given same only, that is 5 meter per second, and here also 15 meter per second, and here time they given as like 5 seconds only, and this was 10 seconds will take. So what will happen? So V1 is nothing but 5, T1 is nothing but 5, V2 is nothing but 15, T2 is nothing but 10, and then T1 plus T2, 5 plus 10. 5 5s are 25, 15 into 10, 150 upon 5, 10 plus 5, that is 15. So 150 plus 25, 175 upon 15. So now I'm with 5 table, 5 threes are 15, and then 5 threes are 15, 5 fives are 25. You get as 35 upon 3. So nearly you get as 11 point, so it is 206, 11.6 meter per second. Here is 6 also it will write. So that is about your another models, and let's move on to the next model. Not next model, next we will go to acceleration. So velocity is completed now. We will go to the acceleration. Alright, so acceleration means, what is acceleration? A rate of change of velocity with respect to time, then that is called as acceleration. Okay, so now here it is acceleration. We will discuss some of the important points about acceleration. What is acceleration? What is the deceleration? So here it is, for example, object is moving. One stone was thrown here, up to here it reached, and then after reaching it will come here again to the back to the ground, right? So it reach up to one place and then it loses its strength and it will come back. So now from when it starts from down to that mid place where that strength will lose, up to that place it will move, that is called as acceleration. And then whichever comes from up to down, that is called as, so we can call as retardation. So we call that as deceleration or retardation. So we can call this retardation or deceleration. Means down coming, that's what it is, deceleration. Upgoing means that is acceleration. So up to this, if you are understood, then I'll tell some of the points to you all. You just remember now how to solve these all points. So now first one, it is the acceleration and velocity of body need not to be in the same direction. So acceleration and the velocity cannot be the same direction. So example, upward it will be acceleration upside and the velocity is going to be the downside. So that's the reason we are saying that the direction may not be the same. So next one, we'll think about that if equal changes of velocity take place in equal intervals of time, however small these intervals may be, then the body is said to be in uniform acceleration. So negative acceleration we can call it as retardation or deceleration. So this acceleration will be, see, upwards will be the positive, downwards will be the negative, that is called as deceleration. Okay, so then the acceleration of a particle any instant or at any point is called as instantaneous acceleration. And what is your instantaneous acceleration? So a bar is equal to d by dt of v bar. So that's what I said, the rate of change of velocity. So at instantaneous acceleration is d v bar upon dt. This you have to remember. Now a body can have zero velocity and non-zero acceleration. So body is possible to have zero velocity and non-zero acceleration. If you want example for this, it is for a body projected vertically up, at the highest point velocity is 0 but acceleration is z. So if you go for here velocity becomes as a 0 and then your acceleration is equal to the g. G is nothing but gravitational force, then only it will come back to the ground. Okay, so that is about the important point. And next, if body has uniform velocity, it has no acceleration. So if body is having the uniform acceleration and there is uniform velocity, it has no acceleration. Remember that. So a body is having uniform velocity and there is no acceleration that time. Okay, so that is about that. And now we are going to discuss what is the value of g. G is nothing but 9.8 meter per second square, meter per second square, or we can write 9.8 meter second inverse 2. This is very important to solve our problems here. G is nothing but gravitational constant, that is 9.8 meter per second square. Okay, so now what are the equations are required to solve these all acceleration problems? That means we can say that the equations of motion of uniform acceleration. So here it is the equations of motion for uniform acceleration. So the first one you already know that v is equal to u plus at, and our second one, these are very important, s is equal to ut plus half at square, and your third one it is v square minus u square is equal to 2s, and your fourth one it is Sn is equal to u plus a upon 2n minus 1. So this all according to the situation we are going to use. And then your fifth one, S is equal to u plus v upon 2 into t. So these are the important equations of motion for uniform acceleration. If you are able to remember this, then it is very useful to solve your problems. So just remember this. Alright, next one. This is very important point. If your body starts from rest, travels a distance sm in nth second and sn in nth second, then what is your acceleration? So acceleration A is equal to Sn minus Sm upon n minus n. So for example, they may ask in this way question that a car starting from rest travels 500 meters in 500 meters in, that is we can write as 30th second. So under one it is not possible. Let me write here 50 meters in 30th second and 100 meter in 20th second. Find acceleration. Then just remember this, distance already given, then seconds also given, just substitute it. So acceleration A is equal to here, Sn is nothing but, so that is how much you got. Sn is here, sorry, it is not 28th second, it is 50th second, right? And it becomes easy. So now here A is equal to Sn is nothing but it is 100. So here let me write first Sn is 100, whichever the final one, and then second it is n is equal to 50, and same method Sm is equal to 50, m is equal to 30. Just substitute those values. 100 minus 50 upon, so Next one 50 minus 30. So you get here 50 upon 20, 0, 0 cancel, you get as 5 upon 2. So 5 upon 2 is nothing but 2.5. So your acceleration is 2.5. Okay, so 2.5 meter per second inverse, that you can complete it. That is about your first one. So here it is, your acceleration you got is in this way. Here what they given it is, so some distance is covered in m second, another distance is covered in n second, then what is the acceleration? So we found it. So that is about your this point, and let's move on to the next point. Alright, next one, it is just like if a particle travels with uniform acceleration and travels distances Sn and Sn plus 1 in 2 consecutive seconds, then what is the acceleration of a particle? So think, and what is going to be the formula? So in the example, what I can say here is, so that first a particle travels along with a straight line, so travels with uniform acceleration and travels distances Sn and Sn plus 1 in 2 consecutive seconds. Then acceleration of particle. They may say that a particle having uniform acceleration and travels distances 50 meters and 155 meters in 2 consecutive seconds only, they may say. To successive. So consecutive, not successive, means one after one. So just like one afterward you get two, two afterward you get three. That is called as successive. So seconds, then what is the acceleration of 1? Very simple, it was A is equal to Sn plus 1 minus Sn, very simple. So what we'll do here, it is, what is your Sn plus 1 here? Sn plus 1 is equal to 155 meters and Sn is equal to 15 meters. And your formula acceleration A is equal to this, both minus you have to do. When you do minus, what you get? 5 minus 0, 5, 5 minus 5, 0, 1, 105 meters per second square. Because your acceleration is meter per second square or meter second inverse. Same method next also, it is if a particle travels along a straight line means like that. So and travels distances S1 and S2 in 2 consecutive intervals of n. So the first interval is S1 and next one it is going to be the S2. And both will be the n seconds. N seconds means, for example, it is 3, this also should be the 3. So both are the same seconds, then each seconds each, then acceleration of the particle is what? So for this, what is your formula is, A is equal to S2 minus S1 upon n square. So here time is n, here time is n into n square. So now for this, it is again very simple. They given us a 3 seconds now, 2 consecutive intervals in 3 seconds, and it may be the 10 meters and another maybe it is 20 meters. Then how to solve? It is very simple. Just A is equal to S2 minus S1. 20 minus 10, 10 upon n square is nothing but 3 square. So 10 upon 9 meter per second. Simple. So in this way you have to solve. These are all shortcut methods. Okay. So now let's move on to the another. Alright, next one point is this. If a bullet, it is very interesting. If a bullet loses 1 by n of 1/nth of its velocity while passing through a plank, means some object, some objection, or we can say that some object is there, or we can say that some obstacle. Okay, plank is nothing but it's an obstacle. Then the number of such obstacles or the planks are required to just stop the bullet. is n square upon 2n minus 1. Such kind of that one problem is given here. If a bullet loses 1/4 of its velocity while passing through a plank, then how many such planks are required to stop the bullet? And it is again very simple. Here it is 1 upon 4th they given. So that what is your n? So your solution is n is equal to 4. And now number of planks required is equal to n square, means that is 4 square upon 2n minus 1. 2 into 4 minus 1. 16 upon 8 minus 1, that is 16 upon 7. So if you want to simplify, 7 2s are 14 and 2 zeros, 7 2s are 14. So 2.2 is possible, means more than 2. It is approximately, we can say that only two planks are required to stop. So this is about your your fifth point, and let's move on to the next point. Alright, next one, listen. So it is very interesting one now. This is a train having the compartments. Think this is a train. It is not train, just think it is a train, okay? There is one pole. This is pole, okay? So this pole was crossed by a train first compartment with speed u. So last one crashed that pole with the speed v. Okay, then what is the speed of the middle compartment past the pole? So this middle compartment speed we need to find. So we need to find what is the speed when this middle compartment is passed on the pole. So just say they given in your question that this was 500 kilometer per hour. This is the first one speed, and second one they given as, means that last one they given as like 700 kilometer per hour. These are the speeds of the first compartment was passed through that pole, and then last compartment passed through that pole is 700 kilometer per hour. Then what is the speed of the middle one? What is the speed of the train when this middle one is crossed that pole? So this kind of questions are very important. So if that is the case, then what is, you have the formula. So you have formula is this. So that speed, that middle compartment speed is equal to square root of u square plus v square upon 2. Square root of u square plus v square upon 2. So now what we can do, square root of, so first u square, 500 square, 5 5 are 25, and if you done the square, what it becomes, these all becomes as zeros or 4 zeros. So plus another one, v square, 7 7s are 49, and again 4 zeros. If 2 zeros are there, 4 zeros. So upon 2. So add both, what you get here, 49 and 25, 0 0 0 0 0 0 0 0 0 0 0 0 0 14 7. So we can get as 74,000. So write square root of 74,000 upon 2. So then cancellation do. 2 3s are 6. 2 7s are 14, 0 0 0. So here one more 0, right? So you get as square root of 3 7 0 0 0 0. So that is about your answer. So which is approximately, it is 606, it is approximately, I'm saying, okay. So you calculate and you can find your answer. This is about your uniform acceleration was there in the one dimensional motion. This is about total. This kind of problems we can expect in your examination. Let's move. In next class we are going to discuss whichever we discussed now, those all previous year NEET questions we are going to discuss, okay. And some practice, I'll give some of the practice problems also, or model questions that you have to solve. May God bless you.